Vijay. Today I am here to present my capstone project on TED Talks view prediction. It is a supervised learning regression model. So here is the summary. TED, what is the full form of TED? It is Technology, Entertainment and Design. So what is the summary of TED? It is an unprofitable organization that posts videos online and free. TED is devoted to spreading powerful ideas on just about any topics. This dataset contains over 4,000 plus TED Talks, including transcriptions in many languages. It was basically started as a conference in 1984 that designed by Richard Saul Woolman, but due to some reason it was unsuccessful. After 6 years in 1990s, it back to the ban. Instead, speakers shared their views and ideas to the society in 80 minutes. As of 2015, TED and its sister TEDx chapters have published more than 2,000 TED talks for free consumptions by masses, and its speakers list boasts of the likes of Al Gore, Jimmy Wales, Shah Rukh Khan, and others. The main objective of this project is to build a predictive model which could help in predicting the views of the videos uploaded on the TED website. This is my GitHub link. You can click over the link and visit my GitHub page. There are more projects in there like unsupervised learning, classification learning, and you can view that project. Let's start with the project. So firstly, I will be importing important libraries. So first, for data manipulations, we have pandas and numpy. For visualizations, I have matplotlib, seaborn, plotly. For date columns, we have one code encoder, ordinal encoder, and so on. These are all the important libraries which I have installed. So let's move to mounting the Google Drive. So I mounted my Google Drives, and after that, I have loaded my dataset in a variable named TED Talks. So this is the first view of the dataset, which contains talk ID, title, speaker one, all speakers, of patients, about speakers, and many more columns. And this is the last three views of the dataset. Okay, here is the description of all the columns. So now here is the information of all the columns. So you can see the column names over here, and non-null count means how many non-null values are present in the column. So we can see. So next we have the D types. What are the types of the columns dataset? So we have integers, objects, floats, so on. So what we have got from this, we have got that recorded date, published date, and comments, they are all in incorrect data type. So you can see this published date, it is in object type. So we will change it in date type. So let's move, checking the null values, if there is any null values present or not. So we can see by calling is null and then summing it up, we can see how many null values are there. So occupation, it has 522 null values. About speaker, it has 503 null values. Comments, it has 655 null values. So I will handle this later on. These three columns have the most higher missing values. So the comment attributes has a lot of NaN values to deal with. We have used some basic intuition for which could be the reason of comments being null. The most logical explanation could be that the comments are disabled for the video. The other reason that could be possible is the data inconsistency. So there could be some issues with the survey that are possibly causing this inconsistency. We will deal with these NaN values later on. So checking the duplicate values. So by calling this duplicated method, we can check the duplicate values. So checking for unique values in native language. So what are the languages? So we will see by calling the unique method in the native language column, we can see all the unique languages: English, French, Korean, Hindi, Italian. So now we will see the quick overview of the dataset by calling the describe method. So we can see the counts of each and every columns, the mean, the standard deviation, the minimum, 25%, 50%, 75%, maximum. So let's move on. So now I have called the describe method again, and this time I am seeing all the percentage. How many, like all the percentage of the columns. So over here you can look that comments starts from 25%, 38, it has 30 values. Moving forward, in 99 values percentage, it has this much values, but in maximum it has this much. So it contains some null values. Similarly, duration column also contains null values, and views column also contains null values. So what we have got, the minimum value of views is 0. The minimum value of comments is also 0. Outliers in views, comments, and duration columns. Okay. So finding rows where column comments have 0 values. So we will be finding the rows where column comments have 0 values. So we have only 2 columns. We only have 2 rows. So 2 rows present where columns, the comments equals 0 values. Okay. Finding rows where column views have 0 values. So we will be finding the rows where column contains 0 values. So we have total 6 columns, 6 rows over here. So total 6 rows are present where views equals to 0 and comment equals to NaN. This is the MCAR data, which means missing completely at random. So we can remove these rows because this is impossible that the view of videos are 0 on TEDx website. Total 655 NaN values present in comments columns, so we have to fill that value also. So moving forward, I'm calling the describe method again. So what we have got from here, there are 2 columns with same name and details, that is speaker 1, all speakers. So one of the column needs to be deleted. So speaker 1 and all speaker, they both are similar column. So you can see the speaker 1 Alex and all speakers with Alex. So I'll be dropping this one of the column from here. Okay, now coming with the summary, what we have got till now. All issues with the data, dirty data, low quality data. Firstly, comments, occupations and about speakers columns are high missing values. I have to fill 655 missing values of comments, which is a completion issue, missing data. Incorrect data type assigned to recorded data, date, published date, comments. Validity issue, invalid data. The minimum value of column views is 0 and there are total 6 rows. So I have to delete the rows. Accuracy issue, not accurate values. The minimum value of comments is also 0 and there are only 2 rows but null values in other 655 rows. So simply fill with 0, but this column is important, so I will fill values in feature engineering part. Accuracy issue, not accurate values. There are 2 columns with same name and details, that is speaker 1, all speakers. So one of the columns is to be deleted. Accuracy issue, not accurate values. URL and TED ID column is also not useful in EDA, so I will drop this column. So number 2, messy data, untidy data. Topics and available language are in list format. I will have to split this untidy data for better feature correlation with views. I will perform this in feature transformation part. There are also few columns in dictionary, untidy format, occupations, about speakers, related talks, but these columns are not important. So in later feature transformation part, I will remove this column if needed. So now I will be coming to the data wrangling part. So first, data cleaning. So firstly, I have copied the TED Talks in a TED Talks dev variable name. So after that, I'm filling the missing values like comments with 0, the missing values which contain stand value. I'm filling it with 0 in comment columns with no data in occupation columns and so on. So by calling the fill in a method. Now let's see, it's there after filling the NaN values, is there any null value present or not in the dataset. So we have 0 null values, except we have recorded data, only 1 NaN values. Okay, change date types of columns. Now I'm going to change the data types. So comments integers, views integers, duration integers, TED Talks integer. Changing these all in integers. These comments in integers, like then recorded date in date time, published date in date time. So now let's look for the data types. So you see it has changed from object to data types, and you can see all rest of the column data types. Okay, now dropping the unnecessary columns. So I am dropping all speakers URL and TED ID. Then I am renaming speaker 1 to speaker, recording rename method. After that, let's look for the sample 1, is the one of the sample of the dataset. Here it looks like. Okay, now I will simply drop the 6 rows where values of view is 0, because in TEDx it cannot be possible that the views are 0 in every video. So it is an like invalid data set. So I will be dropping the rows which contains 0 views. So I have dropped the views 10. Now let's see if there is any views with 0, and there is none. And this is the shape of the dataset containing 3999 rows or records and 16 columns. Now let's move to EDA and feature engineering on features. Before starting EDA, I have to remove some untidy columns that are not required and does not have any correlations towards the dependent column views. So I am dropping occupation, about speaker, related talks, descriptions, transcript, and now this is a sample after dropping the columns. Now moving forward, finding popular talk show titles and speaker based on views. We will be finding popular talks and the titles and who is the speaker on based on views. So we can see I've shorted it from descending. So title to school skill creativity, speaker Sir Ken Robinson, views this many, the highest number of views, followed by your body language may shape who you are, speaker Amy Cuddy, and this many views. So let's see what are the observations. Ken Robinson's talk on Do School Kills Creativity. It is the most popular TED talk of all time with 65.05 million views. Also coincidentally, it is also one of the first talks to ever be uploaded on the TED site. The main dataset is sorted by published TED. Robinson's talk is closely followed by Anne Curdy's talk on your body language may shape who you are. There are only 3 talks that have surpassed the 50 million mark and 12 talks that have crossed the 30 million mark. Speaker. Okay, these are all the observations we have got. Now, let's move on. So now, I'm creating a data frame with top 15 speakers by views. So we can see. Okay, and I have also created a data set with top 15 by comments. So you can see these are the top 15 views by speaker names, how much views you can see over here, and what are the name of the speakers, and top 15 speakers by comments. So you can see the number of comments and the speaker. So what we have got from this observation, that is, in top 15 most popular speakers by views and comments, there are total 6 speakers are same in both categories. I think I will add new categorical column using speakers by popularity, wise categorical columns. Example: good, average, high, extreme, popular using comments and views column by but after performing feature engineering. Okay, checking skewness of the numerical column, float and all columns. Okay, I'm calling these numerical columns. I'm storing it in a variable numerical columns. Okay, now let's see skewness. Now we will we have 0 skewness. So now we will focus on numerical columns first until with outliers, null values, and then check skewness of the columns. So I'm checking the correlation with views column. So this is a scatter plot. So it is rightly skewed. By seeing this scatter plot, we can say it is rightly skewed, and it contains outliers like comments and views. We can see this value. There are more than 6,000 comments, but only views are very much less. So this might be a case of outlier. Why it is happening? We need to look for that. Now, observation which I have got. From the above graph, it is clear that comments and views both are rightly skewed, and they both have somewhat of a similar distributions. This might signify some linear correlations. Also, as previously seen, comments have a lot of NaN values, and also distribution is highly skewed to the right side, indicating some outliers. So let's deal with those issues. So we will see the distribution of comments. So we can see I plotted out this plot, and it is rightly skewed. The tail is totally in right. So observation: the comments column is also highly rightly skewed. So we have to apply log transformation when we make pipelines. There are some outliers in this comment. We have to remove them or use some technique to fill that outliers with other values. Okay. Now printing the outliers or printing the values which are greater than 1100 in comments. We can clearly see in graph the upper code also that there are only 29 values as outliers. Okay, removing outliers of comments column, and so by drop, and we can see the shape now. Okay, fill null 0 value with median of columns. So I'm filling the null values with median in comment section. So you can see we use median to fill null values because median is better than mean in case of outliers. That's why. So now plot this. I'm plotting the plot after removing outliers and fill null values. So this is how the comment now looks like. It is still rightly skewed, but it is better from the above one. So after dealing with outliers and null values, now distribution column comments are right skewed. It is not highly right skewed, but it is rightly skewed. So now checking for views. You can see this view column is also rightly skewed, highly rightly skewed. So observation: the view column is highly right skewed. We have to apply log transformation when we make pipeline. There are some outliers in this column. We have to remove them or use some technique to fill that outliers with other values. Now let's see duration, and it is rightly skewed. You can see not highly, but it is rightly skewed. And now checking correlation of duration and views using scatter plot. Correlation and duration of views using scatter plot. Duration and views. We can see that views and duration has no correlation from here. What are the observation which I have got? That is, from the above graph, it is clear that duration and views columns are not correlated to each other. There are also some outliers in duration columns. You can see there are some outliers in duration columns. Okay, checking duration and views columns outliers using box plot. So we will be checking the outliers using box plot of duration and views. So you can see in views and in duration, The outliers we can see over here. Okay. Treatment outliers by mean. So I will be treating the outliers by mean. So columns, views, and a duration. So I'm looping over here. Now let's see the numerical columns again after treating the outliers. I've treated the outliers in this loop. IQR interquartile range. So I have firstly differenced the 75% and 25%, and after that you can see over here I treated the outlier. Okay, let's see the column. So now there is no outliers present. So after filling outliers with mean, distribution of graph columns, views, and distribution. So this is the distribution. It's tending towards normal. After fill outliers with mean, view columns is little bit rescued with normal distribution, and for duration column are bimodal type distribution. Duration column is like a bimodal type distribution, and it is tending towards a normal distribution, but still a little bit of slightly skewed. Okay, change duration in second, changing the duration from second to minute. Okay, changing the skewness of our numerical column. So in here I'm going to change the skewness of our numerical column. It's view comments and duration. Here it looks all good right now. We focus more on all these numerical columns later on and applying functions on power transformation using column transformation when we make pipelines. Okay, this is the split view of column name views, duration of comments. So observation we got, we can clearly see that when comments value high in 600 to 1000 sites, views value also increases. But in duration time, increase or decrease that are not any changes in views values. Okay. Now creating a new column, speaker popularity in the main data frame and assign the categories. So now I will be creating the new columns, column name popularity, speaker popularity. So on the basis of views. So if there are less than 5 lakh views, it is not popular. If it has greater than 5 lakhs views and less than 15 lakhs, it is average and followed by minimum. Let's see. So now we can see the columns by column sample. Okay, let's go. You can see the popularity, speaker popularity by comments. Not popular, this many. Average popular, this many. Popular, this many, and so on. Observation which we have got. We can observe that this speaker popularity column has a strong correlation with the comments column in an ordinal manner. This means that as the number of comments on a TED Talk video increases, the popularity of the speaker also tends to increase. So now creating a new columns, video rating, column video rating. Okay. So we'll be creating it on basis of comments. So less than 50 comments, I'm giving it a rating of 1, followed by greater than 50, less than 120, 2. Greater than 120, less than 203, and so on. So observation. One of the main ways people engage with content on social media platform, including video sharing platforms like YouTube, is by leaving comments. Now I will be plotting a bar chart of popular topics of TEDx website. So you can see these are the popular topics of TED Talks: science, technology, culture, TEDx, global issues, TED, ED, society, designs, and so on. Observation. As many have been expected, since science and technology is the most popular topics to talk, culture and global issues are also the popular topics respectively. The next question I want to ask or answer is the trends in the share of topics of TED Talks across the world. Has the demand of technology talk increased? Do certain years have a disproportionate share of talks related to global issues? Let's find out. Now, let's see. I have plotted the stack bar chart of 8 topics over the year and check the trends. So, 2009. These are all the topics, and you can see from here, publish here, and the trends. So plotting a line chart, you can see the popularity published here. So the technology talks has steadily decreased over the years, but technology is over the year is number 1 over the year, and since after 2018 animation talks take place. This is understandable considering the boom of gaming industries and also boom of technologies such as blockchain, deep learning, and augmented with reality capturing people's imaginations. There are a lot of discussions and topics in one TED Talks, so we cannot make new columns from this. I tried, but the other rows are duplicated, and if we created broader categories, because some topics may fit in multiple tags, so there might be some overlap issues. Now let's come in future selections. I'm dropping the unnecessary column like speaker, title, recorded date, published date, event, native language, available language, and topics. So these are the features. So again I'm changing the details, and we can see the info. this is the correlation matrix. So what we got from here, that is we have to predict the dependent column, that is view. So I cannot modify it or make new columns out of this example, like per year views, related topics, views, daily views, etc. Comments and available languages are most correlated with columns views. We have also some best categorical columns like speaker, popularity, and paid event type that help our model to predict more accurately. So these are the observation. So I plotted the peer plot over here. You can see the peer plot. So moving. Now I will be moving the multi-collinearity. So I have called the various inflation factor library and applied the VIF. So we can see I have applied the VIF over these features. So publish year, it has the highest collinearity. So what are the observed column published year and published months? What is the published month? Okay, but highly correlated. So months ago, published months ago, are highly correlated with each other and have high VIF. We can remove one of these columns and check VIF away. So I'm dropping the published month ago column. So checking the VIF. Now it seems okay. Now the samples. These are the samples. Okay. Johnson transform for views columns and then we train split. Okay. Power transform. I'm using the power transform in the views column. So power transform is really good option. So we apply our comments, duration, available languages when we make pipelines using column transformer. Okay, I checked all columns including individually, and after applying power transformer, skewness is decreased and give results very close to zero. Okay, now model implementation and preprocessing. Now we will be coming to implement these all things and making a predictive model. Firstly, I split the data set in x and y variable, that is x is independent variable and y is dependent variable. In x, I have moved the views column since it is the since we have to predict from the view column, so it is dependent variables which are stored in y like y variable. Okay, let's display the values of y, x. So these are x and these are y's. Okay, calling the trend test split. So by calling the trend test split library. So now I have split the data in 80-20. So this is the shape of x trend and x test. Okay, now data preprocessing using column transformation to make pipelines. Now I will be making a pipeline using this step. So I will be calling the column transformer, then transformer, then I will be setting the standard scaler, power transformer, one hot encoder, ordinal encoder, and especially I will be like calling these categories, these things in ordinal encoder. Now I will be displaying the pipelines. So why I have used the column transformer? By utilizing a column transformer, we can effectively or efficiently apply multiple pre-processing steps such as scaling, encoding, and functions transformation to our data in a single step. This simplifies the pre-processing phase and allows us to build pipelines with different algo, performing hyperparameter tuning to find the best results of our model. So firstly, I am implementing the linear regression. So what is the linear regression? Linear regression is a supervised machine learning algorithm where the predicted outcome is continuous and has a constant slope. It is used to predict values which within a continuous range rather than trying to classify them into categories. So I'm setting pipeline 1. Firstly, in step 2, what I did, I have like applied the linear regression and called this linear regression. Then I've set it pipe 1, and now I've called dot fit and predict. And you can see these are the scores, R2 scores, adjusted R2 scores. Then performance metrics, MA, mean square error, and proof mean square error. And this is the graphical representation of how accurate the graphics. So now I will be applying this I will be using rich L2 with hyperparameter tuning. So firstly, what is rich regression? So it is in rich regression, what we do, we add a penalty term which is equal to the square of the coefficient. The L2 term is equal to the square of the magnitude of the coefficient. We also add a coefficient lambda to control that penalty term. In this case, if lambda is 0, then the equation is the basic OLS, ordinal least square. Else, if lambda is greater than 0, then it will add a constraint to the coefficient. So now I've set the parameters, then grid search, then in step 3 I call this regression, and I've set the pipeline, and you can see we have got a score, that is cross validation score is this 88%, you can say, adjusted R2 score 88.7, you can say, and you can see the MAE, MSC, and RMC, and the graph, predicted graph. The blue line indicates the predicted one, and the yellow line or orange line indicates the actual one. So next, let's come to the observation part. That is, After performing hyperparameter tuning on different regression models, we found that the voting regression models independently outperformed the random forest regression. Although the difference was not significant, both models showed strong performance and were very close in terms of their predictive accuracy. So we can, this is the observation of stacking regression I used again to see the scores and the prediction. So let's come to the conclusion. Okay, after evaluating multiple regression models on the dataset, random forest regression performed better than other models. They have higher R2 scores, lower error metrics, and can generalize well on unseen data. Voting regression and stacking regression are ensemble techniques that combine multiple models to make predictions. The voting regression model showed excellent performance, outperforming all other models, although the difference in performance between these two models, voting regression and random forest regression, was very small. We ultimately chose to use the random forest regression in our scenario. This scenario decision was based on the fact that the random forest model is generally more interpretable and easier to explain to stakeholders compared to the voting regression, which aggregates predictions from multiple models. Additionally, the random forest algorithm has been shown to perform well in a variety of regression tasks and can handle non-linear relationship between features and the large target variables, making it a more robust choice for our use case. Therefore, based on the evaluation results, the random forest regression was chosen as the best model to achieve our objective. Also, in future, we can try implementing some other optimizing techniques to wind up with better results. So these are the hyperparameter tunes, getting data R2 and not just R2. At the end, a word of thank you to you for going through the project to the very end. Genuinely appreciate your time. Happy New Year.